What's happening, everybody? Pastic back one more time for another one of these here algebra videos. And here we are going to be working on function rules, tables, and graphs. We're going to represent functions using equations, tables, and graphs. So the first one says to model the function rule. Model the function rule with a table of values and a graph. So let's do that. The function rule is y equals 1/3 x plus 2. That looks like a normal equation. Well, this is how you make it a function notation. I said in one of my other videos that y and f of x are the same thing. That's because they are. This is just different types of notations. It's kind of like metric and inches, you know, meters and inches or centimeters and feet, whatever. It's just two different ways to do the same thing. Okay, so don't get confused by that. So it says using a table of values. So I want to be purposeful with my table of values. I want to choose inputs that make sense. If I look at this function, I want to look at what's happening to the input. X is the input. Those are the values for the domain. Our domain values should be numbers that are divisible by 3. Why do I say that? Because what happens here is you're taking 1/3 and multiplying by that input value. So if I do 1/3 times 2, that's 2/3. 2/3 plus 2 is 2 and 2/3. That gets a little messy. So I want to try to pick useful and easy values. That's going to be a very important idea as we move forward through this unit. So since we're multiplying the x value by 1/3, I want to pick things that are divisible by 3. So the first value that I'm going to pick is 3. So I'm going to say f of 3, instead of just putting y equals 1/3 times 3 plus 2. Well, that's going to equal 1/3 times 3 is 3/3, which is 1. So 1 plus 2, which is 3. So what I've just done is found out that the input of 3 has an output of 3. And that is the first point. So now I'm going to use two more values of x that are divisible by 3, and I'll be right back. So you can see I've chosen two other values to input for x. I've chosen 0. F of 0 equals 1/3 times 0, which is 0. 0 plus 2 is 2. So I have an input of 0 and I get an output of 2. F of -3 equals 1/3 of -3 plus 2, which is -1 plus 2, which is 1. So I get the point -3, 1. Now my last step is to graph them. So I'm going to graph -3, 1. I'm going to start in the origin, in the middle, go left 3, 1, 2, 3, and up 1. And my first point will be right there. So I'm going to plot the other two, and you should do the same. So you can see I've plotted my 3 points. And if I look closely, it looks like there is a pretty constant pattern from left to right. It looks like to get from the blue to the red, I go right 3, up 1, and then right 3, up 1. So that's something I want to start to think about. What are the patterns that we see? So if I were to draw a connection between these points, what's it going to look like? It's going to look like a straight line. This is a linear function. So whenever I see something that looks like this, with no exponents, no fancy mumbo jumbo, just something times x plus or minus something, it's going to be a straight line. Going back to the inputs that I chose, you're going to notice I chose values that were divisible by 3. Why did I do that? Because you have 1/3 times x. So 3 is divisible by 3, 0 is divisible by 3, and -3 is divisible by 3. I chose purposeful values that were divisible by 3, but I also chose 1 positive, 1 negative, and 0. That is often going to be one of the things you want to do. Sometimes you'll need a few more points. Sometimes you'll need 5 or so points to see what's happening. But oftentimes with linear equations, you can get away with 3 as long as you are purposeful in your decisions. So pretty much the same idea here. It says at the local video store you can rent a video game for $3. It costs you $5 a month to operate your video game player. The total monthly cost C of V depends on the number of video games V you rent. So they're telling you that the number of video games is V. Number of video games is V. Use the function rule C of V equals 5 plus 3V to make a table of values and a graph. So the first thing I want to do is I want to organize my information. they've given me this function rule. I want to know what I'm talking about when I write about it. So C of V equals 5 plus 3V. Well, this tells you that the independent variable, the input, is V. So V equals number of video games. And C equals the cost. You can even write C of V equals the cost. But that's kind of how I think about it. You got the input on the inside of the parentheses, the output on the outside, which would be C, right? But C of V is technically the whole output. So it wants us to make a table of values. So again, we want to be purposeful in our choices. We're talking about real things here. So I always think, okay, I'm talking about video games. What's the smallest number of video games I can own? That would be 0. So the first number I'm going to plug in is 0. So I write that out. C of 0 equals 5 plus 3 times 0, which is equal to 5 plus 0, which is equal to 5. So I've just found the point 0, comma 5. That's always a good place to start with an input of 0 when you're doing a real world situation. The input of 0 is always going to give you the y-intercept, and the y-intercept is very, very frequently the best place to start a graph like this. So 0, comma 5, we're talking about video games for our inputs. I'm going to choose a couple more and do out the math, and I'll be right back. So I've chosen my 3 inputs. I only chose 3 again because if I'm comparing this function, C of V equals 5 plus 3V, it looks very similar in its construction to the last one. So just by looking at it, I know it's going to be linear. And to get a line, all you need is 2 points, and I did 3, just to make it a little bit more detailed. So I got my 3 points. I've got to label my axes, so I know I'm going to put the independent variable or the domain values on the bottom, and that would be number of video games. And going on the vertical axis, the y-axis, I'm going to put the cost. And I'm going to put in parentheses that we're doing dollars. So the last thing I got to do is figure out what I'm going to count by. So for my x values, I start at 0, and I got to get up to 10. Let's see if do I have 10 lines? 1, 2, 3, 4. It looks like I have 10 lines, so I can count by 1 for the x-axis. And my highest y value, I've got 35. I start at 5 and I go to 35. So 5 and 35 are both multiples of 5. Probably a good idea to count by 5s on the vertical axis. So I'm going to do that and I'll be right back. So I've labeled my axes, and now you can see that on the bottom I'm going by 1s. I've skipped 5 lines and put a 5. That means I'm going by 1s. And on the vertical axis for y, I'm counting by 5. So I got 5 on the first one, then I skipped 4 lines and I put a 25. Then I skipped 5 more lines and I put a 50. So I'm counting by 5s. You can put them all there if you want. I just don't like to have too many numbers because then it gets all muddled up and confusing. Next thing I'm going to do is graph my 3 points, and I'll be back after that. So I've graphed my 3 points and I've color coded them for you. Again, 0, 5 means I go right 0, up 5. So from the first line I put a point. 5, 20 means I go right 5, up 20. And 10, 35 means I go right 10, up 35. So I want to notice a pattern here that I see. I see from the red X to the orange X, or whatever color that is, kind of vomit yellow. I go right 1, 2, 3, 4, 5, up 1, 2, 3. And I go right 1, 2, 3, 4, 5, up 1, 2, 3. So it does indeed form a line. If I wanted to, I could put some more points on there, but honestly, this is fine. If you wanted to, you can try and estimate some more of them. But I wouldn't put anything else. This is pretty much all you need. At this point, you have a good enough graph for your function. I would not draw a line here, and here's the reason. If I draw a line, then I'm going to include every value in between these points. If I include every value in between these points, then I'm including fractions and decimals, and I cannot have a fraction or a decimal number of video games. So I'm just going to have solid points on this graph. So the 3 that I chose are the only ones that are going to stay. Just know that there are more points. I'm just not graphing them because I have enough to show the general idea of what's happening here. All right, so this one says to graph the function y equals, you got to remember this from earlier, y equals the absolute value of x plus 2. So absolute value, you have to remember that whatever you put inside of that, you're finding out how far that number is from 0. So this one is going to look different than the line graph. So far we've only done things that were linear. when you do this one, you're going to be purposeful in your choosing of your inputs again. So remember in the line graph a couple of slides ago, I chose negative value, a 0, and a positive value. I'm going to do the same thing here, but I'm actually going to do 5 values as opposed to 3. So knowing what this function looks like already is an advantage for me, so you make sure that when you do this, you remember what happened so that you can use it for next time. So my values that I'm going to choose are -2, -1, 0, 1, and 2. Those are pretty standard values to choose when you're graphing something. They don't always work to give you the best picture, but oftentimes they give you a pretty good idea. So for my inputs, the first one I'm going to do is -2. So f of -2 equals the absolute value of -2 plus 2. And you might want to get in the habit of just writing f of x equals y somewhere so that if someone looks at this, they know what you're talking about. The absolute value of 2 is how far is -2, excuse me, how far is -2 from 0? It is 2 from 0. So this is going to be 2 plus 2, which is 4. So we have 1 point of -2, comma 4. Then I'm going to do the rest, and I'm going to come right back. Y'all should do the rest too. I'm going to plug in -1, 0, 1, and 2. So I've gone ahead and I've plugged in my 5 values. For -2, I got 4, which was one I did together with you. -1, I got the absolute value of -1 is 1. 1 plus 2 is 3, so -1, comma 3. And then I plugged in 0, 0, the absolute value is 0, plus 2 is 2. Then you're going to notice when you get to the positive sides, the absolute value of these positive numbers down here are going to be the same as the absolute values of these negative numbers up here. So what you're going to notice is a pattern, hopefully. 4, 3, 2. It went down by 1, now it's going back up. 3, 4, and you see some symmetry here and here. You're always going to see that kind of symmetry when you're graphing an absolute value function. So now what is this going to look like? So let's plot these points. Let's start with 0, 2. 0, 2 is right here. I'm going to go to -1, 3. -1 is left 1, up 3. That's right here. -2, 4. Left 2, up 4 is right here. And I got 1, comma 3, which is right here. And then I've got 2, comma 4, which is right 2, up 4, which is right here. So if I look at all of those combined and I connect it, you've got a cool little shape which forms a V. Absolute value graphs always are going to form some kind of V. They can be flat, they can be steep, but they will always form some kind of V shape. I guess I shouldn't say always, but honestly, the only time where they don't is when you multiply them by 0. If you multiply them by 0, you're basically just going to get a flat line, so a horizontal line, so you really don't need to worry about that too much. But for the most part, know that when you're graphing an absolute value function, it should be in some sort of V shape, upside down or right side up or sideways or who knows. Cool? Cool. So this is our last one for this section, and this one wants us to do the same, but it's a different type of function. So we've had linear functions in the first two, we had an absolute value function in the third one, and now we have what's called a quadratic function. So this is called a quadratic function because it's got a power of 2 for its highest exponent. Highest exponent is the power of 2. Wonderful. So we want to graph this. We're going to do it pretty much the same way. I'm going to pick 5 input values for my domain, and I'm going to get 5 output values for my range. So I'm going to select -2 through 2 again, and I'm going to do all that out. You should do the same, and join me once I unpause. So I'll be right back. So real quick before I do the rest of them, I just did -2, and I want to talk you through it. So I'm plugging in f of -2, which means I'm going to put parentheses around my input. It's a very good habit to get into. Put parentheses around your input in all of these function rules. Very good habit to get into. And then make sure that squared, that exponent of 2 goes on the outside. A very big difference. Because if I do -2 in parentheses squared, I'm going to have -2 times -2. That's what that means. So that's going to end up being 4. If you were to do -2 squared like that in your calculator, it's going to give you -4. It's going to give you the wrong answer. It's the right answer for what you wrote in the calculator, which is -2 squared without parentheses. But what we're trying to do here is actually square the value of -2. That is not what this does, so this is bad. This will give you a mistake unless the function is written with a negative on the outside. So I'm going to keep going with this, and you should do the same. I'm going to do -1, 0, 1, and 2. So I've plugged in all 5 of my inputs, and I've gotten 5 points. And again, this is quadratic, a new type of function, but I want you to notice a little bit of symmetry again with this one. Just like the absolute value, similar symmetry. You got 6 and 6 on both sides. You got 3 and 3 on both sides, and you got 0, 2 in the middle. This middle point, when you know it's directly in the middle of all the other points from left to right, in the middle of, when I say in the middle, I mean like in the middle of the symmetry, on the line of symmetry, that's going to be called your vertex. So this little guy, 0, 2 here, is called your vertex in this case. So we're going to draw that one first. 0, 2 would be right here. And then we've got, I'm going to do -1, 3. So -1 will be left 1 up 3. And I'm going to do -2, 6. -2 up 6. Up 6 would be there. And then I've got 1, 3, which is there, and 2, 6. So you're going to notice this symmetry. If you draw a line right down the middle on the y-axis, it's going to split the graph, in quotation marks, in half, right? So it's like a line of symmetry, the y-axis in this case. And when I connect these, I'm not going to have that same V shape that I had for the absolute value. I'm going to have more of a smooth curve. Why am I going to have a curve as opposed to two rays, which is what I had in the last one. If you look back here, I've got a ray starting here and going this way, and I've got a ray starting here and going this way. Those are two linear components of that graph. This one, you have a curve. Only ask yourself, why is there a curve? It's because of this power of 2. That power of 2 means that as things get larger, they're going to grow even faster than they did when they were smaller. 1 squared is only 1. 2 squared is only 4. Right? That's a difference of 3 between 1 and 4. But now when I do 3 squared, that's 9. That's a difference of 5 from 4 to 9. So you're talking about a more rapid growth rate as you get further and further away from that vertex. This point in the middle here, again, is called the vertex. So that's a quadratic function. That's my graph. I've talked for way too long in this video. I apologize, but I hope you learned something. And I will catch y'all on the flip side.